Hello, and welcome to Intermediate Algebra, Unit 2, Lesson 1, Solving Single-Step Equations. Our lesson objectives are to be able to solve equations where the variable is multiplied by a constant, and to be able to solve equations where the variable has a constant added to it or subtracted from it. And here is an example. First of all, what do we mean by solve? If the instructions for a problem say solve, it means you need to find all of the values that could replace the variable and result in a true mathematical statement. Solve x equals 6x plus 8 means find what number you can use to replace x to have a true statement. So since 6 plus 8 equals 14, the solution is x equals 14 because it is true that 14 equals 6 plus 8. There's only one solution because there are no other numerical replacements for x that will result in the true statement. Now, that's mostly what we'll deal with. We'll have one solution, but a little later on in the course, we'll see problems like this. We're asked to find all the numbers we could replace n with to make n squared equal to 4. And this has two answers, 2 because 2 squared is 4, and negative 2. Now, you have to be careful in your calculator. You have to put that negative in parentheses. I'd like to believe you could square negative 2 without your calculator, but just in case, you have to put it in parentheses because in your calculator, if you do this, you get negative 4. So that has confused more than one student. Don't add your name to that list. Okay, so let's move on to an example of what we're doing. Solve 3x equals 24. This is objective 1. Now, you have to ask yourself, you're trying to get x by itself is the other way to look at solving. You say, well, the 3x equals 24. The x is connected by multiplication. The opposite of multiplication is division. So if the variable is multiplied by a number, you have to divide to undo it. So we have this, we have 3x equals 24. And to undo the multiplication, we divide. And when I write a fraction line like that in a 3, it's the same as saying 3x divided by 3. You'll have to pardon my handwriting, it'll get better as the semester goes on. So I can't just do that to this side though, I have to divide the 24 by 3 also. And we will use fractions. We will hardly ever see this in this course. We use the fraction bar to be our division symbol. So the reason I divided by 3 was because 3 over 3 is a 1. And that's what I want. I want 1x. I want to know what 1x equals. So we don't usually write the 1. X equals, and if I do 24 divided by 3, I get 8. So 8 is the solution to this equation. It will make 3x equals 24 true, and I check it like this. 3 times 8 equals 24. Yes, it does. Okay, so let's move on to the next one. So this one, what I want you to do is take a look, decide what you have to do to get x by itself, and write out the steps. Pause the video right now and try it. Okay, you're back. So let's see, when we go through this one, I see that the x is connected by multiplying. There's an understood multiplication symbol. We don't write it, but when a number is written right next to the variable, the number is called the coefficient, and it is multiplied by the variable. So I'm going to divide by a negative 5. And if I do that on this side, I must do the same thing to the same side to keep that equality, to keep that balance. So negative 5 over negative 5 is a 1, so they reduce. And I get x equals a positive 65 divided by a negative 5 is a negative, sorry about that, negative 13. So that is how you solve that one. Let's look at another example. This one's a little different. The x is divided by 3. X over 3 might be the way you say that, but what it really is x divided by 3 equals 5. So the other way to think of this is 1/3 times x. So this has a coefficient of 1/3 or it's divided by 3. You can look at it either way. 1/3 times x equals 5. I like to look at it when it's just a number underneath. I think of it as divided by. So to undo division, I multiply. So I have x divided by 3, and I multiply that times a 3, equals 5 times a 3. Now this right here is very confusing to students. When you have a number that does not appear to have a denominator, though it does have a denominator 1, times a fraction, you just multiply the number times the top. So what I get is 3x over 3 equals 15. The 3 divided by the 3, the 3 divided by the 3 gives me a 1, so I get x equals 15. So that one's a little different. We divided, there was division in the problem, so we multiplied. The other way to look at it would have been to look at this 1/3 x, and if you do 5 divided by 1/3, you also get 15. So when you divide by a fraction, it's the same as multiplying by the reciprocal. Oh, sorry, that's a 1. And you also get 15. So either way you look at it, that's how that one is done. Next example. 3x, okay, we have multiplication and division. You can look at it as two things going on, or you can look at it as this is 3/4 times x equals 7. So 3/4 times, I said times, that means it's multiplication. I can divide by 3/4, divide by 3/4. Now, this is a 3/4 divided by a 3/4. Anything divided by itself is a 1. That's why I chose 3/4. Now when I do 7 divided by 3/4, it's 7 times 4 divided by 3, because to divide by a fraction, you take the reciprocal and you turn it into a multiplication problem. So this gives me 28/3. That's one way to look at this problem. The other way, some students who understand fractions seem to like this following way I'm about to show you, is if I look at this as multiplying by 3 and dividing by 4, well, I multiplied by 3, so I've got to divide by 4. So I've got to divide by 3, and I divided by 4, so I've got to multiply by 4. So I'm going to multiply this side times 4/3 for the purpose of making the 4 times the 3 and the 3 times the 4 be on top of each other and become a 1. But I also have to multiply this by 4/3. And if you go back in the video a little bit, you see this is exactly what I ended up having to solve to get my answer. So 4/3 times 3/4 is 1. A fraction times its reciprocal is, a number times its reciprocal is always 1. Equals, and again, 7 times 4 is 28. And I do not need to worry about, oh, it's an integer. If it's just an integer times a fraction, you just multiply by the top. That's because there's an understood 1 there. And when you multiply fractions, if you have a over b times c over d, what you get is a times c over b times d. Multiplying fractions is easy. What you don't like to do is add and subtract. That's where you need a common denominator. Multiplying and dividing is actually fairly simple. So when you have a fraction times the x, or 3x divided by 4, you can just multiply by the reciprocal. Let's go to the next example. Now this one is very similar to the one we just did, because I have 2 times x divided by 5, and I still want to get the x all by itself. That's what I want to do. So in order to get the x by itself, I either need to divide both sides by 2/5 or multiply both sides by 5/2. Dividing by 2/5 is the same as multiplying by 5/2. So I get 5 over 2 times 5 over 2. This becomes 10 over 10. You get just an x equals 40 over 6, which reduces to 20 over 3. If you're good with your fractions, you could have seen that this reduced right there, and there's your 20 over 3 also. So this one isn't done any differently. You just have a fraction on the other side. It's the same as example 4 other than that. So let's go on to the next ones. Now, we have several here for you to try. The next slide gives you the answers, but each of them are like the examples we just did. So if you try them and get them right, excellent. If you try them and don't get them right, then go back in the video and review the problem types that you missed. So pause the video now, try these, then check your answers. Okay, you're back. Here are your answers. And hopefully you got the same ones. If you didn't, you could go back to the examples we did. They're very similar. I threw the negative in on number 3 here that you didn't see in the other fraction 1, but that should not make a difference. You're just multiplying by a negative to get a positive x. Now, the next topic, solving when the variable has a constant added or subtracted. I want the x by itself, and I know that x plus 3 equals 10, but I want to know what is just x. So what I do is I subtract 3 from both sides. If I subtract 3 here, now some of you may have seen this done out horizontally. I like to write it vertically. So I do x, and there's no x's to combine that with. Plus 3 minus 3 is 0, so I don't have to write it. 10 minus 3 is 7. That becomes my answer. So the question you have to ask yourself, why didn't I divide? Well, I didn't divide because this is addition. I need to undo addition. Subtraction undoes addition. In the prior examples, division undid multiplication and multiplication undid division. You have to decide what is the x connected to that you need to remove to get the x by itself. Here's another example. Again, I see I have x minus 6 is negative 3, so I have a 6 subtracted from x. So I'm going to do the opposite, which is add. So that basically I end up adding you could think of it this way, I end up adding 0 to x. That gives me x all by itself, so x is 3. We don't typically write that 0 though. So negative 3 plus 6 is a positive 3. Now this one sometimes seems confusing because it looks like, well, there's nothing in front of the x, and people tend to want to divide when they see this. But if you see this plus sign, you're either going to add or subtract the number on the other side of it. So I have a negative 8 added to an x. To zero out the negative 8, I have to add 8. You could think of it as you're zeroing out the number that's added to the x. So if I add 8 on the left, I must add 8 on the right. I chose 8 because it will make that become a 0, and I get x equals 12. Next example, 5 plus x equals 2. Again, when we see the 5 out here, people want to divide. This plus sign says they're not connected by, 5 is not connected by multiplication to the x. 5 is connected by addition. So I need to zero out what is added to the x. To zero out a positive 5, I add a negative 5, or I subtract 5. That's the same exact thing. 5 minus 5 is 0, so that leaves me just an x over here, equals negative 3. Now I suspect you're doing these in your head. Stop it. Write them down like this. I expect to see work. What if you knew to subtract 5 and you just made a silly mistake, which I'm prone to doing myself, and you wrote negative 2 instead of negative 3? If all I see is this answer, I have no idea what you did. There's no partial credit, and there's nothing there to help me correct what you're doing wrong. The more of your work I see, the more I can help you correct and find more efficient ways to solve. So now, here's another collection of them. I'd like you to try these. Stop the video, try them, and when you're done, start the video again, and the solutions will be on the next slide. Okay, you're back. I'm trusting you to believe that means you did them on your own, and you're about to look at the answers. Here they come. Okay, so in the first one I subtracted 15 from both sides. The second one I had to add 10. The third one I had to subtract 12. And the fourth one I had to add 6. So hopefully you got those. If you didn't, you can go back and look at the examples again. And thank you for joining me for this edition of this lesson in intermediate algebra.